In early 2020, astronomers spotted something extraordinary hurtling towards our Sun. A comet designated C 2019 Y4, but better known as Atlas. And for a moment, it seemed poised to become the astronomical event of a lifetime. But what happened next, and the questions it raised, have left scientists both fascinated and, dare I say, a little unsettled. Initially, Comet Atlas was just a faint smudge, but it was brightening at an astonishing rate. Predictions flew across the internet. Some said it could become bright enough to be seen with the naked eye, even during the day. It was on a path remarkably similar to the Great Comet of 1844. Leading many to believe that Atlas was a long-lost fragment of that spectacular visitor. Imagine a piece of a legendary comet returning to put on a show for a new generation. The excitement was electric. Every new observation showed it getting brighter and brighter, building anticipation for its closest approach to the Sun. But then, just as the hype reached its peak, something strange happened. Atlas stopped brightening. In fact, it started to fade. It was like a firework that fizzled out before the Big Bang. Astronomers around the world trained their telescopes on it, trying to understand what was going on. And the images they captured were stunning. The comet's solid nucleus, its core of ice and rock, had shattered, instead of one solid object. The Hubble Space Telescope revealed a ghostly procession of smaller icy fragments, each trailing its own tail of dust and gas. The great comet had disintegrated before our very eyes. So why would this terrify scientists? It's not about fear in the way we think of a monster movie. It's a deeper, more profound kind of concern. The disintegration of Atlas highlights a cosmic truth we often forget. The universe is a chaotic and unpredictable place. Comets are essentially dirty snowballs, ancient relics from the formation of our solar system about 4.6 billion years ago. They hold the original ingredients, the primordial soup from which planets, and maybe even life, emerged. When one breaks apart, it's like a time capsule shattering before we can open it. Think about it. These comets are messengers from the distant past. By studying their composition, the types of ice, the organic molecules locked within them, we can piece together the story of our own origins. We want to know what the early solar system was made of. Did comets like Atlas deliver water to a young, barren Earth? Did they seed our planet with the complex carbon-based molecules necessary for life to begin? Each time a comet like ATLAS disintegrates, we lose a priceless piece of that puzzle. It's a lost opportunity to read a chapter from the very first book of our solar system's history. The terror for scientists is the realization of how fragile this evidence is. Atlas wasn't hit by anything. It likely just fell apart under the gentle but relentless pressure of the sun's heat and radiation. As it got closer, the frozen gases inside it began to heat up and expand, a process called out. It's possible this process became too violent, spinning the nucleus faster and faster until it simply tore itself apart. The very thing that makes a comet beautiful, its glowing coma, entails also the mechanism of its own destruction. This fragility has huge implications. For years, we've talked about missions to land on comets, to drill into them and analyze their pristine material. The Rosetta mission, which successfully orbited and landed a probe on Comet 67P, was a landmark achievement. But Atlas reminds us that not all comets are created equal. Some are just too delicate. It forces scientists to rethink how we approach these celestial visitors. How can we study something that might fall apart before we even get there? It adds a new layer of difficulty to some of the most ambitious space exploration plans. Furthermore, there's the question of what these fragments become. The breakup of a large comet creates a dense stream of debris. When Earth passes through such a stream, we get a meteor shower. While most of these are harmless, beautiful light shows, the disintegration of a massive object like the one that produced the 1844 comet and ATLAs raises concerns. What if a much larger fragment were on a collision course with Earth? The breakup of Atlas is a small-scale demonstration of a process that could, on a cosmic timescale, pose a genuine threat. It's a reminder that the orbits of these objects are not always stable, and their structures are not always sound. This isn't about causing alarm, but about appreciating the scale and power of the cosmos. The story of Atlas is a perfect example of science in action. It started with a discovery, followed by excitement and prediction, then a surprising twist, and finally, a deeper investigation that led to new knowledge. We learned that comets can be incredibly fragile. We learned that predicting their behavior is far from an exact science, and it reinforced the importance of continuously monitoring the sky. The universe isn't a static, clockwork mechanism. It's a dynamic, evolving environment. Comets are born. They journey through space for millennia, and sometimes they die spectacular deaths right before our eyes. The terror isn't about an imminent threat, but the awe-inspiring and humbling realization that we are trying to understand forces of nature that are immensely powerful and fundamentally unpredictable. Atlas may not have been the great comet we hoped for, but it became something more, a ghostly messenger that taught us a valuable lesson about the beautiful, fragile, and wild nature of our solar system. Thank you so much for joining me on this cosmic journey today. If you enjoyed this exploration of the mysteries of space, don't forget to hit that like button and subscribe for more deep dives into the universe. Let me know in the comments what other celestial mysteries you'd like to unravel together. Until next time, keep looking up.